All right, now we have log base 4 of x. If we put in a value of 1/4 for x, what is our y value? So I'm going to come down here. Y is equal to, and it's not even y, it's k. K is equal to log base 4 of 1/4. Well, 4 to what power is 1/4? That power is -1. So I know that when x is 1/4, the y value is -1. So 1/4 -1 is about there. We always go through 1, 0. Log base 4 of 4 is 1. Log base 4 of 16 is 2. So here's my graph. So I wanted to find 3 other points where a and b are integers, and I did that. So now I'm going to sketch. Try to go through your points. I think I need to take my graph and move it up just a little bit. Okay, so let's move my points down a bit. All right, so I'm going to clearly label my integer points, and that should be 16, not 15. So let's put that on there. So I have 16, 2, 4, 1, 1, 0. All right, use the laws of logs and transformations to sketch this graph. So I know that my division means subtraction. So I'm going to come down here for C. G of x is log base 4 of x plus 2 minus log base 4 of 4. Well, log base 4 of 4 is just 1. There's nothing I can do to split this up. I can split up products but not sums. So my graph has been shifted to left and down 1. So I'll come over here and graph that. So 14, 1, 2, 0, -1, -1. And now my asymptote gets moved 2 to the left. So x equals -2 is my asymptote, and I can make my picture something like this. And that is my g of x. Okay, my graph to find the domain. So domain, x is greater than -2. Without looking at the graph, though, I could look at my original input. I know that x plus 2 over 4 has to be positive. That means x plus 2 is positive, and this implies that x is greater than -2, which matches the domain that I see on my picture.